So last time we learned about molarity, and we did a couple of problems, or we did at least one problem using that new formula. And so since molarity has to do with the moles of solute compared to the liters of the solution, it shouldn't be any surprise to you that our old friend stoichiometry is back, and that we're going to now use molarity as it pertains to stoichiometry. Okay? So remember what molarity is. Molarity, we designate with a capital M, is moles of solute, right? Just to see this formula one more time, over liters of solution. So you just want to make sure when you're doing these problems, if you're given the solution in milliliters, make sure that you convert it to liters first. But that's the relationship, the concentration unit that we'll use that relates moles of solute to liters of solution. All right, so let's do a problem where we use this in a stoichiometric calculation, and that is on page 271, example 9.4. And example 9.4 says this: a chemist is doing the following double displacement reaction. And so we're given this formula that 2AgNO3 aqueous plus MgCl2 aqueous is going to give us 2AgCl as a solid. You remember that? We've looked at that. What is that? We call that a precipitate. That's the solid that emerged whenever we combine these two aqueous solutions, plus MgNO3, and there's two of those. That's aqueous. All right, so we're given this equation here, and it says if the chemist starts with an excess of MgCl2 and 150 milliliters of a 2.0 molarity solution of AgNO3, how many grams of AgCl should precipitate out of the solution? All right, so let's see, we have excess MgCl2, so that one we're not really that concerned about. 150 milliliters of a 2.0 molarity solution of AgNO3. Okay, so we have 150 milliliters. That's going to be, you should be able to do this in your sleep now, right? That's going to be equal to 0.15 liters. 0.15 liter solution of a 2.0 molarity, 0.15 liters of a 2.0 molarity solution of AgNO3. And the question is, how many grams of AgCl? So grams of AgCl is what we're looking for. How much of that precipitate are we going to make? All right. So we've got, since we know that molarity is equal to moles of solute over liters of solution, then that means that 2.0 molarity is equal to some number of moles of AgNO3, right, divided by 0.15 liters of solution. All right, so we basically multiply 0.15 times 2.0 molarity, and we're left with the moles of AgNO3 equals 2.0. Remember, molarity is moles per liter, right? Multiply that times 0.15 liters. So our liters are going to cancel out here, and we're left with 0.3 moles of AgNO3. All right. Now, given that, what we've learned in stoichiometry is that if I have the number of moles of one of these compounds in this chemical equation, then I can figure out the number of moles of another compound, right? And so we know we can then convert 0.3 moles of AgNO3 to moles of AgCl, because that's what we're interested in. We're trying to determine the number of grams of AgCl, right? Because we know that 2 moles of AgCl, 2 moles of this is equal to 2 moles of that, right? Okay, so if we have 0.3 moles of this, these units are going to cancel out, and we're going to have 0.3 moles of AgCl. So that's how many moles this 0.15 liters of this 2 molarity AgNO3 solution will produce. But we weren't asked the number of moles, we were asked the number of grams, right? So the final thing that we have to do is convert this from moles to grams, and we know how to do that, right? We find the atomic mass of AgCl, and that's going to give us the number of grams that we have per mole. And so we just go to our periodic table to look that up. We see that Ag is 107.87. So we'll just do this up here. AgCl is 107.7 is the Ag plus. Let me make sure I wrote that down right. 107.87. Sorry, 107.87 plus Cl is 35.45. 35.45. So that's going to equal 143.32. 143.32 grams per mole, right? And so now we can use that to convert this. We know then for every 1 mole of AgCl, we have 143.32 grams of AgCl. Those units cancel out. And finally, our answer is 43 grams of AgCl. All right. So we can use molarity in stoichiometry. All right, let's do one more problem, just to practice that one more time. And this is example 9.5. It says a chemist wants to make 300 grams of calcium hydroxide. 300 grams of calcium hydroxide. And the formula for that is CaOH2. 300 grams of calcium hydroxide using this equation. And the equation is CaCl2 aqueous plus 2NaOH. 2NaOH aqueous. It's going to yield CaOH2. There's the calcium hydroxide. OH2. And that is a solid plus 2NaCl. And it says if the chemist has a 3 molarity solution of NaOH, so a 3.0 molarity solution of NaOH, what volume of that solution will he need to use? What volume of that solution will he need to use? Okay, so let's start by taking our 300 grams of CaOH2 and let's convert that first to moles, because we know if we're working with molarity, we're going to have to convert our grams to moles. That's what we have to work with. And from that, we should be able to use this to get the number of liters of this solution here. All right. So this is this process we're going to take. We're going to take this. We're going to convert that to moles, just using the atomic mass. And then we're going to use the stoichiometry. We're going to convert from the number of moles of this to the number of moles of NaOH. And it asks what volume of this solution do we need? We're given the molarity of the solution, but what volume of this molarity solution do we need in order to produce 300 grams of calcium hydroxide? And so since we convert this to moles, and then from that we can determine the number of moles of this that we need, we should be able to use the molarity here and determine the liters of that solution, okay, which is a volume unit, and it asks for volume. All right, so CaOH, what is CaOH2? CaOH2, the atomic mass of Ca, when we look that up in our periodic chart, is 40.08, right? Plus, we've got 2 oxygens, right? So it's going to be 2 times 16 plus 2 times 1.01, because we have 2 hydrogens. And so we have, what was the number? 74.10 grams per mole. So now we can use that to convert this to moles. So 300 grams of CaOH2. We know that 1 mole of that is going to be 1 mole of CaOH2 is equal to 74.10 grams of CaOH2. And so that leaves us with 4.049 moles of CaOH2. So we can convert that using stoichiometry to the number of moles of NaOH, because that's the solution that we're interested in, right? So if I take this, I can multiply it. I know that for every 2 moles, no, what is it? Every 1 mole of this, so if we have 1 mole of CaOH2, that's going to be equal to 2 moles of NaOH, right? And so that means that 8.098 moles of NaOH is what we need. Now again, the question for the problem was what volume of that solution will need to be used. And remember, molarity is moles of solute, right, over liters of solution. And so what we have right now is we have the moles of the solute right here, 8.098, and we have the molarity, which is 3.00 molarity. And so we can figure out if this is true, then it means that the liters of solution is equal to the moles of solute over the molarity, okay? And so we plug in our moles of solute, 8.098. Try to make that 8 a little more readable. Moles of NaOH divided by the molarity, which is right here, 3.0 molarity solution. And remember, this unit is actually, we could rewrite that unit as moles per liter. That way we see that indeed our moles are going to cancel out, leave us with the unit of liters. And so we're left with 2.7 liters. That's our final answer. Okay? So that is how we would use molarity and stoichiometry. And you'd better believe that's going to be on the test, right? Any opportunity for us to play around with stoichiometry, since it's such so commonly used in chemistry, we're definitely going to take advantage of that. So make sure that you understand that. All right? So let's go ahead and talk about one other topic. Let's talk about molality. And molality is another concentration unit that, whereas molarity relates the moles of solute to the liters of the solution, molality relates the moles of the solute to the mass, to the kilograms of the solvent. Okay, so this is the definition of molality. Molality, this is the equation for it. Molality is moles of solute divided by the kilograms of solvent. All right. So here we're not talking about the total amount of the solution, right? The total liters of the solution like we were with molarity. Here we're relating the solute to the solvent. The moles of the solute, not to moles of solvent, but to kilograms of solvent. Okay, so that's an important distinction. And when we get to our next topic, you're going to see why it's so important that we understand molality and why we need to be able to do that calculation. The unit for this is just simply, just like for molarity, the unit was a capital M. For this one, the unit is a lowercase m. Okay, so if you see a little m, it means molality. If you see an uppercase m, it means molarity. Okay, and again, the difference, right? Molarity relates moles of solute to total liters of solution, right? To the volume of the solution. Okay? Molality, on the other hand, molality is an uppercase m, molality is a lowercase m. that relates moles of solute to kilograms of solid. So one relates to a volume unit. It's the total solution, the volume of the entire solution. One relates to the mass of the solvent. All right, so let's do a quick example, like this is going to be one of the easiest examples we've ever done. And it's on page 274, and it says, the chemist dissolves 50 grams of AlCl3 in 350 grams of water. What is the molality of the solution? So pretty simple. It's just that they give us grams here, and we need this in moles, right? We know how to do that using the atomic mass, and they give us this in grams also, but we need it in kilograms, right? Because this is the solvent in this problem. So we'll first convert AlCl3 to grams. AlCl3, we look it up, 26.98 plus 3 times, what was Cl? Cl is 35.45. That's the atomic mass, and so that's going to give us 133.33 grams per mole. Okay? So that's what we're going to use to convert 50 grams of AlCl3. We know that 1 mole of that is equal to 133.33 grams. So when we do punch that in our calculator, that gives us 0.375 moles of AgCl3. All right, and then 350 grams of H2O. Let's go ahead and convert that to kilograms. 350 grams. We know that 1 kilogram is equal to 1,000 grams, and so that's going to equal 0.35 kilograms of H2O. All right, so now we just got to plug that in our equation here. The molality, lowercase m, is equal to moles of solute, which is 0.375 moles of AgCl3, divided by the kilograms of solvent, which is 0.35 kilograms of H2O. And so we get 1.07 moles per kilogram. But remember, our unit for molality is just the lowercase m, so it's going to be 1.07 m. And that's our final answer. All right, so we'll see in the next section why it's important that we understand molality, because the formulas that we're going to learn in the next section are dependent on molality. See you then.